Hello everybody, it's Chris Schmidt from Rocket Lasso, and I've got another tutorial for you today. In fact, this is tutorial number 10 out of 10 weeks, so that was a goal I was aiming for. I might start doing like every other week because it does take a lot of time to make these. However, in this tutorial, we're going to be running some pretty complex dynamic simulations on some fairly high poly objects. And on those objects, it's going to run pretty slow. So the goal is to swap those out for some low poly proxies. Specifically, we're going to be using spheres, which calculate really smoothly, really accurately, and really quickly. However, we have to build rigs to make them adopt the shapes of the more complex things that we have. So that's going to be one of the main goals. In addition to that, we're going to make it extra difficult on ourselves by working at a really small scene scale. We're going to try and build it in a real world scale. And dynamics behave very differently if it's large or small. And you know, the default cube or sphere in cinema is actually quite large. And if you're working from models or downloading things, you want to work at a real world scale so everything matches. So making everything scale down to the smaller scale is going to just, I think, be useful information, but it's also going to be a lot more challenging. Here we are in Cinema 4D S22, although I think these techniques should go all the way back to 12.5. This is pretty much what we're aiming to make by the end of this. Now, it's not a simple setup. However, in the future, I'd love to tackle some more complex dynamic interactions and setups. And in fact, we were making something more complicated than this, but we ended up finding really good information that I thought made for a more self-contained tutorial. So this is the goal we have, is to be able to run this type of simulation, and not only run this, but run it fast and very accurately. And here's the best part is if we actually do get here, and it's hitting Control D, this is running at 5 steps per frame, which is incredibly good. It's really low, and you'll see that this is running at 90 on my computer, is running at about 90 FPS and running really fast and really accurate. That is our goal. Of course, I like in these tutorials to make everything from as scratch as possible. So that is the goal. The only thing we're going to keep is this pinball. Copy that, open a new file, and paste it. Reset that to 0 on the PSR. Hit the letter S to zoom up on it. And we can see we've got a ball bearing here, and the scale of that is down at 1.35 centimeters. And that is the scale of the standard ball bearing that is inside of a pinball machine. So with that being the scale that we're aiming for, let's continue. Now with this zeroed out, you can see my Z-axis is forward, and I always like using Z-axis forward. So we'll be making a bunch of different mechanisms here as we slowly step through, and let's essentially build it wrong before we build it right. But even in the wrong part that we're building, we will use all that geometry, so there's not going to be much redundant work here. So if you're following along, feel free to make every little part of this. Now, as I said, we are working at a very small scene scale. Everything's very tiny because, well, let me even show you. If I were to create a new sphere, this is a default sphere in cinema. It's gigantic. And if we scoot this over, you can see we get this tiny little ball bearing. It's like whenever you see those videos or posters of the size of Jupiter as compared to Earth, this thing is huge as compared to the tiny one that we're actually working from. In fact, the regular sphere, you'll see, is 100 units on the radius, and now we're about 1 unit of radius. So this is 1/100th the size of a normal scene scale. So before we do anything else, let's change our dynamic settings. Hitting Control D, or on the Mac, Command D, we can go to Dynamics, Expert tab, and we have 2 settings we want to change. Our scale, the scale of the scene that we're looking at. So that can drop down divided by 100. Of course, that just will be 1. But just to be clean, type in divided by 100, and we have 1. And then we have the collision margin. I'm not going to go too deep into it right now. I've talked about it before. But the collision margin tends to be, it's sort of like this invisible force field around your dynamic objects that makes things calculate more accurately. But in this case, we're so small that the collision margin, the force field you can imagine around your dynamic object, would be almost as big as the object itself because it's set all the way up to 1. So that also needs to be divided by 100, which is 0.01 to be the scale. Essentially, that should set us up so that everything should behave decently similar to what it would in a larger scene file. That's the plan anyway. However, with everything being a lot smaller, gravity will feel tinier. Everything kind of runs a little bit quicker, but I think that is actually visually more accurate. Anyway, with all of that out of the way, let's begin building our mechanisms. First of all, we can make something to visually represent the motor. So I like doing that just with a cylinder. I'm going to begin a lot of my objects by setting the radius to 1 just to make it approximately the right size. And then we can scale it up from there. Z plus for the orientation, and for the motor, Let's just increase that to be about that. We'll probably change it in a little bit. This ball bearing is going to get in the way, so I'll scoot it away. And we need our cog. We need the cog wheel to make the gears. That's under the spline menu under cog wheel. Now, if you zoom out a little bit, it's like, why is it a circle? Well, it's because it's actually the hole in the middle of the gear, so it's really big. We could change the radius and all that, but once again, we're working at about 1% of the scale of everything, so that seems like a good default scale to work at here. In that case, hitting T, I will click anywhere in the viewport and start dragging down. You can see the percentage appear right in the center. If I hold down Shift, I can drop this down to 10%. Of course, we're not at 10%. We're supposed to be at 1%. So I'll scale it down again to 10% again. So we went to 10%, 10%, which of course is 1%. And that's going to give us our sort of overall scene scale. Holding down Alt as I create my extrude will automatically make this a parent of the cogwheel. It's automatically offsetting a correct orientation in R22. I actually don't like that when you're dealing with dynamics and things moving around. Sometimes it can pop to a different orientation. So I like automatically setting the direction to Z. I want it on that orientation. It's really long right now, so setting that down to 1 should give us a pretty good looking gear. Now that we're seeing our base gear scale, this motor back here can be scaled up to whatever. It's just, this is really just a visual. So that will be the motor that's counter rotating on this shape. Let's just start right away by making it dynamic. So stay organized, rename the cylinder motor, this extrude, name it gear 1. And this motor, I mean, technically it can be dynamic, simulation, collider body. So it's dynamic, but it's not moving anywhere. Then on the gear, right click and add the simulation rigid body. These are both dynamic objects. If we hit play, the gear will fall out of the scene, of course. We need them to be connected somehow. So rewind all the way. There is an issue where I haven't been getting really good refreshes. I think in S22, there might be a refresh bug. However, if you click rewind, things don't return the way they should. You can hit the letter A, which forces a refresh in Cinema, and that should pop everything back to where it was. Time is 0, hit A. This is currently falling out of the scene, so we need to stop it from falling out by using a connector. We can find that under Simulate, Dynamics, Connector. It's going to be huge by default. Everything's going to be huge because we're working at a real world scale. So under display, we can say, hey, be tiny. Drop that down to 2. 1 or 2 would be good. If I want to see this more visually, I can pull it forward and you see we've got this nice connector. By default, under the Object tab, you can see it is set to type hinge, which means it can spin around on one axis. By default, it's Z positive, and that's why I like building at Z positive. Cinema tends to say Z plus is forward, which is why this is automatically set up correctly. So with that in mind, I can put it back to 0. I just wanted to see it. I want this object to be able to spin around on that axis. So for that, under the connector, under the Object tab, we have Object A and Object B. Object A will be the gear. Now, I'd like to hit play right now. However, there's a weird thing I found when it comes to the extrude lately, and when it comes to the extrude and dynamics, and that is if I were to hit play right now, this connector should stop it from falling, but it's actually going to fall. And it took me a long time to figure this out. It's that, and hit the letter A. The reason that's not working right away is under the dynamics tag, under our shape, so under collision, currently it's applying the tag to the children. It doesn't view it that way properly for some reason. If we want to actually see this gear the way we want to, we have to change the inherit tag to not apply to children, but a compound collision shape. That's all we had to change on that. So with that done, we have a connector that's connecting this gear to nothing. So if I hit play, it's just going to sit there. It can't fall away, and there's no force being applied to it to make it fall. So it just stays there in space. If we wanted to, we are free to drag Object B. That can be the motor. But it's not going to visually change anything. If we're not moving that motor, then that doesn't really add much, but you can do it if you want to. With that applied, we want to see this thing spin, obviously. So to do that, I think it'd be a good idea to, let's create a simulate dynamics motor. Motor's huge, under display, drop it to 2. This motor is going to be driven from the motor, so we can make it a child of that just to keep organized. Now, in the same way that this connect did not have to affect both objects, we don't have to have it affect both here. So in this case, I could just say, hey, Object A, you are the gear. You're getting a force applied. If you're inclined to, or if this was a fully dynamic object, you could drag the motor geometry in as Object B, and those are now kind of linked to that way. Doesn't make a visual difference here, and effectively it doesn't make any difference for our current setup. However, if we now hit play, we should see our gear begin to spin. It is spinning on the limitation of the connector that we set, and it's spinning based on the speed and torque from the motor. Let's organize this a little bit more. Pause, rewind. Always remember, make your changes to dynamic setups at the time of 0. If you make changes later, it can mess things up in a big way. For the cleanup here, actually, it's pretty clean. I'm just going to move this connector to be a child of the gear, extrude, and that will make it a sibling of the cogwheel. If you do the wrong order, then it might actually the gear is still seeing that interestingly. However, just make sure that your gear is above it, and that can just hang out as a sibling of the cogwheel. And it still continues to function the exact same way. Hit play, it's still going to spin. Cool. Now, before we go too much further, I want to be able to see these gears spin more accurately. Right now, you can see, actually, if I deselect it, you would think that that gear is spinning left very slowly. However, if I select the gear, you can see it's actually spinning to the right very quickly. The reason for this is, if you see a car driving down the highway, you see the rim spinning, and if the car hits a certain speed, it looks like it's spinning the opposite direction. That's the effect that we're seeing here. I want to see it a little more clearly. Let's create a simple material for ourselves. Double-click in your material manager down here to make a new one inside of that material. In fact, I like double-clicking it to pop open the material manager. We don't need any reflectance. Under color, I'll feed in the gradient shader, and under gradient shader, that can be radial, which will do the spiral. And I think it would look even better if we select the points, set the interpolation to step, and then if I were to scoot this over, we can see that we could just get this little slice. If I want to be extra fancy, I could grab a second black knot here and scoot it over, and we get a little bit on each side, so we get more of a little pie wedge look. And that's just a way of us being able to very easily drop that onto the gear, and we can see the orientation. And now, even if I don't have it selected, we can more accurately see what direction it's spinning. That will help us later on as we start changing our gear ratios. And I think that's a nice basic setup. This is a good time to save now that we have one gear working. So that will be, for me, I'll save it as 5A because there's a lot of testing to get this working. Gears and spheres. If you're like me and you like reverse engineering files, then I have a Patreon set up, and if you support on Patreon at the engineer level, then you actually get access to all of these scene files, and you can deconstruct what I made, and you'll see the scene files as I save them here in there. Okay, with that out of the way, we've got one gear and it's spinning. There's something I'd like to point out right away, and that is the default settings in this motor are a little bit weird. It's trying to hit an angular speed that's really fast. This is trying to spin really quickly, but it's got a relatively low torque. So this is actually not giving us a very good visual representation of what's happening. What I'd way prefer is that we're saying, you know what, actually, I have a very slow speed that I want to achieve, but I wanted to try really hard to get there. So I'm going to swap this to a target speed of 10 and the torque of 1000. So there's a lot of power behind this motor, but it's not trying to spin that fast. So hitting play now, we should see this spinning a lot slower. And now you can see, okay, we do have good control over that. It's spinning at this speed. It's a little slow now. Maybe jump it up to 55, and that seems more reasonable. Get something rotating a little bit. Now, the scene file is a little bit short, so I think we can jump this up to, let's say, 999. Drag this to expand to the entire thing. And now we can see that we've got our motor spinning for about 1,000 frames. Cool, that's a nice basic setup. Let's make the next gear. It shouldn't be terribly difficult. We've got everything we need already. The way to begin this, I'll collapse that down, create a copy of gear 1. In this case, hold down Control or Command. I can drop it in between, and we see it appears. Rename it gear 2. Selecting that entire extrude, I can scoot it off to the side. And I want there to be more gears on this. In this case, I'm going to set the cogwheels teeth count, and this is all default so far, the teeth count, I want this to be jumped up to 40. So we're going to make twice as many teeth. Now, by doubling the teeth, it didn't just increase the number of teeth, it also doubled the radius. Essentially, almost all these numbers went double, but you'll see that the teeth size on this is the same. That tooth is practically identical to this one. And that's because this is a very smart gear, and it's doing a lot of the math for you. So that's actually a really powerful addition. We have a second gear that should perfectly slot into this one. It's a really great start, and we get that for free. Now, pretty much everything's set up properly. If we were to scoot this in to be interlocking on there. Now, don't go too far. I think I'm not sure in reality how far you want this gear to be, but we want it to have a little bit of space in there. You can see about the gap I'm leaving, and that seems to work pretty well. The last thing we need to change is under the connector. You can see that this is because we copy and pasted, it is currently looking at gear 2, but it's still trying to link to the motor. We don't want it linked to the motor. I want this to just be floating in space. So under object B, clear it. With that being empty, that means that this gear is going to just stay right where it is and it's allowed to spin on that axis. So changing nothing else, we can hit play and immediately these gears are fighting each other. Okay, why is that happening? Well, that's happening because we didn't change the type of collision that these should be having with each other. So selecting both dynamics tags, under collision, you can see that we did make a compound collision shape. However, we didn't change the shape. Now, here's something that's pretty useful. If you hit Control or Command D, under Dynamics, you can click Visualization. And under there is an Enable checkbox. On frame 0, you won't see anything because Dynamics haven't calculated yet. However, if we hit play, you'll see it suddenly show a representation of what is actually calculating. And because we're letting it automatically decide what the shape is, it's actually calculating this as a concave shape, meaning there's no pits in it. There's no little divots anywhere. Now that's quicker to calculate, but it's not accurate for what we want. And these two shapes are essentially being calculated as cylinders, which means they can't intersect. So we need to change that. Specifically, let's rewind, never make changes except at 0. Selecting those two tags, the shape should be moving mesh. That means it's looking at every single polygon, every single point. Now, if we hit play, first of all, we'll see it spin properly, but you can see it's actually calculating everything. Now, here's a problem, and this is what a lot of this tutorial is about, is that with all of these polygons being calculated, there's just so many calculations happening. Every single one of these polygons is actually even divided into triangles. So every triangle is having to do a calculation to see if it's intersecting with other planes in the scene. And I mean, Dynamics is pretty smart where it's only worried about colliding with something if these two white boxes, these bounding boxes, are colliding with each other. But you'll see that that's just so many calculations going on. It was even so much more than we just had that cylinder shape. Having said that, this is still running pretty well. I'm going to turn off that visualization. So Control D, don't enable visualization. And now we can see that one gear is indeed turning the other one. It's working quite well. So, that's a pretty good place for that to be. I'll save over that existing scene file, Control S, because we haven't changed too much. And this continues to work pretty well. Now, let's make things fancier. Let's make a gear that's going to be kind of, increasing the gear ratio by translating from one size gear to a different size gear. And we'll even merge them into one object. So here's the thought. Gear 2, duplicate that, scoot it off to the side a bit, rename it Gear 3. Here's the idea. I'm going to put that into a group or hit Alt-G to put into a null. So that's in a null. I want 2 gears. So I'm going to duplicate Gear 3 a second time, scoot it forward. You do not have to be precise with this. Just make sure it's not intersecting. Actually, it doesn't even matter if it intersects, but I'm going to make sure that they're not quite touching. So there's 2 gears there now. The second one, the one in front, grabbing the cogwheel, I'm going to drop its teeth down to 10. Is it 10 I want? Maybe I want 20. No, we'll do 10. 10 should work. So this is now a 4-to-1 ratio. There are 4 times as many teeth on that outside as here, and it's also 4 times the radius on that one. So that's interesting automatically. Grabbing this null, which I will rename Gear 3, and now that we're in the world of these nulls, I wouldn't mind these going back to just being called extrudes. So selecting both of them, I can right-click under Basic tab, say Reset to Default, and they go back to being extrudes. So all the magic's going to happen now on this null. Scooting that backward, I want to just eyeball this and make these gears properly interlock. So we still want that same kind of gap in there. And that seems pretty good. So we have 1 gear in front. Let's make sure they're not intersecting. Like a little bit. Actually, they're pretty close here, so I will scoot that back a little bit extra, just so there's a gap in there as well. So now we've got a more complex gear, one that's going to be changing its ratio from 1 to 4, something to keep in mind. Now, as I said, we want our dynamics to run not on these individual gears, but we want them to be treated as one object. Really simple. I can just scoot one of these dynamics tags up to the top gear and delete the other tag. So this is now saying, hey, everything below me, 1 compound collision shape. Calculate the entire moving mesh. We have 2 connect objects inside. We don't want that anymore, so I will delete one of them. Scoot the other one as a child directly of Gear 3. It's still in the proper spot because we moved the entire thing over. So this is in the correct spot in here. However, now the connect should not be connecting to one of these extrudes, which is what it says. It should connect to gear 3. That's the overall shape. So dropping that in, I think that should be all we need to do here. So hopefully I can just hit play, and there we go. Now we have this gear translating into this one, and that one's translating the small one, which is then making the big one spin. Now, even though these are both spinning at the same speed, a lot fewer teeth are passing by as this little one rotates. You can see that we kind of get 1, 2, 3, 4, 5 teeth going by. Over here, it's like 1, 2, 3, 4, 5, 6, it's like so many teeth are going by. So we've actually increased the speed of our overall setup. So this is where things start getting interesting when you start playing with gears. And I just love the mechanisms of things like gears and translating them and making worm gears and translating things into like that locomotive arm lever moving back and forth. There's so many cool combinations. Now that we have built gear 3, I think it should be pretty straightforward to make a gear 4. So dragging gear 3, holding that control to make a copy, rename it gear 4. Let's just scoot it in the proper location, which would just be scooting this over, moving it backward, and make sure that these are intersecting properly. And even the way that Cinema makes the gears, you can see that they're even kind of correctly locking into each other from this orientation, which is also pretty nice. Scoot that back. Once again, leave that little bit of gap in there. If you leave them too close, then actually you can create a problem. I'm not sure if this will work or not, but I'm going to scoot it like very close to it, and maybe it'll work, but I'm not sure. If I play, I wouldn't be surprised. Yeah, you see it's kind of getting locked in there. It's a little too close. Rewinding back to 0, scoot that away. And now if I hit play, hopefully that's starting to work. There we go. So now things are going to hopefully start getting even more interesting. What should be happening is every time that we do this again, each subsequent one is going to spin 4 times as fast because we got a 4-to-1 ratio. So we can keep on increasing the speed. Now, one of our advantages here for the purposes of this tutorial and kind of learning more about it is that every time we are gearing this up, we're making the motor work even harder because it's a lot harder to turn another gear faster than it was before. So I think even now, try and pay attention to how fast this middle one here is spinning. It's actually taking, look how slow it kind of speeds into its, until it's getting up to speed. And now look how slow that's going. If we were to rewind and scoot this a little bit away so they're not, interlocked, if I hit play, look at this. This is getting up to speed quicker and it's spinning faster. So this is now heavy enough that it's starting to make our motor strain a little bit, even at 1,000 torque. I'm going to hit undo to re-lock these, and we're in a pretty good position here. I'll save it as a new scene file as 5B. And I think I would like to make this work even harder. Let's do a gear 5, because why not? Make this work even harder, 4 times harder, in fact. Same idea, scoot it over, eyeball it, move it over. And I'm intentionally being a little bit sloppy here. We could be very precise with our numbers and move everything over very accurately. But you can see that this is actually decently forgiving. If you scoot them too close together, they might seize up, but this is it's pretty forgiving. Hitting play, let's see what we end up with. Okay, well, it's not liking something. Let me make sure that I didn't mess something up, or maybe we're finally hitting that limitation. First of all, let's just make sure it's working. Hit play, and yeah, that's still spinning, so that's good. Scoot this back in again, and let's make it not quite as close. Hit play, and there we go. Okay, I think I just was a little bit too close, so it seized up. Now you can see that this is starting to spin, and now look at that one. Remember how before we were seeing how fast it was going? Look how slow it's going now. They're having to fight their way through every single one of these. So there's a lot of work being done here, and that really powerful motor is starting to struggle. In addition to that, I want you to pay attention to our FPS that I have here. I have the FPS up in the HUD. And if you're inclined to turn on FPS, I just really like it being there so you can see what is causing things to slow down. You can get to it by hitting, Alt-V. And if you hit Alt-V as a shortcut, you can jump to your viewport settings. You can also manually do it. I always do the shortcut, but I think under view camera, I'm not even sure actually where it is. Default line options. Yeah, under options you can go to configure, and that's how you get to that menu manually. So under here there's a section called HUD, and under HUD you see I have frames per second turned on, and that's giving us that feedback. So with this current setup, you can see it is working, but we're losing a lot of FPS because as these collide with each other and they're struggling to move forward, this is dropping down to 37, jumping to 40, 39. It's jumping around quite a bit, as low as 33, 31. It's jumping around a lot depending on how many polygons are colliding with any other polygons in any given moment. The calculations take a different amount of time. But the main thing I want to be looking at here is this ratio and how it's being affected and how it's making this motor work a lot harder than it was originally. Couple things that we need to keep in mind here. And actually, let me hit a quick save right there. It's a good spot. Couple things to keep in mind. We could crank up the torque more. And one of the main things we do is kind of eyeball this, look at the speed that this is taking, or see how many frames it takes. Let's say how many frames it might take for that to get to the right side. You see it took about 250 frames for that to be on the right. We could try cranking up the torque. That's a pretty straightforward thing. Because of the order of operations here, I might move the motor up just because it's the first thing happening. It doesn't actually change anything. I just want to be more organized. Selecting the motor, we can crank up the torque. Let's say the torque is 10 times stronger, so the motor is 10 times as powerful. Hitting play, let's see what we end up with. Well, we still have to get up to speed, and this is still taking a while to rotate. And let's see, right as that gets to about there, it took about the same time. So we've really increased the amount of power that we're feeding through here, but it's not really improving our situation as far as speeding this up again. So what's actually going on here? Well, one of the major variables is how much all of these gears weigh. Currently, we're in a very, very small scene. And if you have tinkered with dynamics a bunch, you might know that under the dynamics tag, under mass, we have something called world density. And essentially what that means is it's taking the calculated volume of the object and multiplying it to the world density. So right now, 1. So what would the density, and if you take density times so density being 1 times the volume, you get mass. How heavy is it? Technically, these gears are so small, even, they look big in the screen, but keep in mind that cinema is used to objects that are this big. So these are quite small. The weight of this gear here, I actually calculated it out using Espresso earlier. And it is like it's 0.0005. It's really, really tiny, very, very light. And that's because we made everything really small. Now, the only thing that really matters here is if everything is correctly in ratio to each other. So what I've actually been doing is changing the world density to a custom mass. Changing custom density doesn't do too much because it's going to be you can do a different multiplier on them so they could all become heavier or lighter. But in this case, we can just say, no, here's an absolute value. All of these are going to weigh some amount. So I'm going to say, yeah, the mass of these is 1. So it's got a mass of 1. This has a mass of 1. That has a mass of 1. If I put this on a giant cube, it has the same weight as the same tiny one. The mass is completely independent now. Now, with all of these weighing the exact same amount, a mass of 1, if we hit play, let's see what we get. Okay, everything is still working in ratio here, and that seems to work quite nicely. Now, let's just pay attention to this speed thing. First of all, I think it did speed up a decent amount. In fact, yeah, remember we were saying how long does it take to get to right about here and right there, and it looks like I was about at 100 frames. And by the time we get to 250, this looks like it spun around like 2, maybe 3 times. So this is definitely already working better. Now, here's the main thing to keep in mind is we care about the ratios between them. And now this is going to be a little bit fake. If you try to make everything like super accurate, then this is not necessarily adding to that. But what we could do is say that these different gears weigh different amounts relative to each other. So if this very first gear weighs a lot more, then as the motor applies its weight to it, it's like, well, I'm really heavy. I can move other things more easily. So let's see what that ends up doing. And keep in mind that it took about 100 frames for that to spin 180. If I just take this very first gear and you know what? You are 10 times heavier than you were. Let's hit play. And immediately look how quick that spun. Like it's actually really hard to see it. Boop, it got there in like 40 frames. This gear is heavier. The only thing we changed was the weight of this gear, and you can now see that it's spinning that up. So something we could do as this begins filtering its way down would be to make the first one heavy and the next one a little lighter and the next one a little bit lighter. And as we make these lighter, they're more easily pushed around by something that's heavier. It's a pretty straightforward intuition, but it is something that we can control here, which is pretty cool. So if I were to maybe make the mass of this last one 0.1, so it's a lot lighter, and I rewind and hit play, look how quick it's getting to that point now, just by changing that last one. It's only taking like, 10, 15 frames to get to that halfway rotation point. So it's really quick. And all we did was make the first one heavy and the last one light. And you can see how dramatically different this behaves and how much more quickly it gets ramped up to that point. Now, some things to keep in mind, that does work, and it's a way of introducing more motion into each of them. And like I said, it's a little bit fake. But even with all of this improvement, we're still running at that same FPS. We're still running about 32, 34. Like I said, there's a fluctuation depending on how many things are calculating. So that is our basic overall idea here. Now, I think we're at a point that we could start paying attention to some additional variables, and that is how long it's taking for this to calculate and some imperfections we might get. It might take a little bit to see it, but I think if we zoom up on these gears here, I definitely saw it happen. Yeah, you can see them. Let's hit NB so we can see it. You can see that these gears are starting to pass through each other. And that's because it's just not doing polygon on polygon intersections are just not accurate enough to be able to handle all the forces that are at play at this in this type of setup. So this is where we can start to speed it up and to make it more accurate. That is the plan. So this is a good place to leave this one. We didn't change too much. I'll just save over the previous scene file. Quick save there. And let's remake this from scratch. And we can even do it step by step as we translate them. So that's what we'll do. This very first gear is where we will begin. That gear, let's turn off the extrude so we just can see the cogwheel. And there it is. So just seeing that cogwheel, we want to create a low poly proxy, but we're going to go as extreme with that as we can. And that is, instead of making a low poly proxy, let's replace it with a series of spheres, a series of tiny spheres. Now that should be pretty much at 0, 0, 0. So creating a sphere, it's going to be huge. I'm going to eyeball this because it's actually a pretty forgiving method. Hitting T for scale, scale down the sphere, scale down the sphere until I want this to be approximately the size of one of these teeth. So let's go to a flat view. And in fact, this sees it from the front, and I think we want it to be viewing it from the back so it's consistent. So from the back, now you can see it's lined up the same way our viewport was. So scooting this sphere up to one of the gears, I want it to be kind of centered on it. I am not going to be overly precise here. T for scale, and I want this to scale so that the width of the sphere is about the width of this tooth at its widest point. I'm not even worried about it getting all the way to the tip there. Just right like that should be good. Now, we want to make as many spheres as we need teeth. Obviously, the best way to do that is going to be to use a cloner. Holding down Alt, the cloner will become a parent of it. The mode shall be radial. Make sure it's on the correct plane, the correct orientation. And right now, everything's on the Z axis. So clicking on the one that doesn't have Z will be the correct one because that means we're facing on Z. Unfortunately, the radius is really big. So if I set the radius down to 1, we're now going to see the proper radius. Now, everything got scooted up because that's where the sphere was. So on the cloner, I'll reset the PSR. And there it gets zeroed out. And I believe that this should be a radius of 2. We're working at very specific scales, and it just turns out that the scale that we scaled everything down to, a radius of 2 is going to be incredibly accurate for us. Now, we know that this very first gear has 20 teeth. If you're not sure at any point, you click at the cogwheel, 20 teeth. So on the cloner, a count of 20 should give us what we're looking for. It's doing a good job overall, and they're matching in the spot quite nicely. They're just not quite lined up. Now, you could rotate it, but even more than rotating it, I like grabbing the offset and the cloner and just increasing that until they line up. You could also go negative, but increasing is just as good. If you want to be really accurate, you could type in a very precise number. I could also just overshoot in there. That seems to line up pretty well. But of course, you could type in, a 31.5 and do half the amount. Actually, 31.5 and make the match a little bit more. The more accurate you are, obviously, the better it's going to be. It doesn't have to be crazy accurate. But there we go. That's looking pretty good. We've now got some spheres ready to go. They're actually just barely interacting with this next gear. So if we were inclined, we could scoot them forward a little bit. Let's not worry about that quite yet. What I'd like to do is pretty much steal a lot of our stuff from the gear. And I'm going to ignore the gear for a little bit and just steal all of its material. So I want its dynamics tag, because we already did a lot with that. In addition to stealing its dynamics tag, I probably want its connect. So we could pull the connect out. Now you can see that we can't make it the connect the child of it because then it'll start cloning it. We don't want that. So instead, the cloner needs to be grouped, Alt G, to put it into a null. And the connect can be pulled out as a sibling of the cloner or of the null. So that seems to be working just fine. Now, just like we were already filtering the shape down from the top level before, maybe we can move the dynamics tag all the way to the top. And that can be named Gear 1. In fact, I'm going to name it Gear A just to distinguish. These were 1 through 5, so we'll make Gear A and work through some letters instead. So that is now the dynamic object. It should be filtering down. The connect object, I want that to be linking not to gear 1, but to gear A. And inside the dynamics tag, we can make some changes as well. Specifically, under the collision, it's a compound collision shape, which is good. That means all these spheres will be treated as if they're one object. But the shape shouldn't be a moving mesh. Now it can be an ellipsoid. It can calculate as a sphere. Now, let's hit play and see what happens. And I wouldn't, before I forget, the motor is currently still trying to drive gear 1, but we need it driving gear A. So motor, don't drive gear 1, instead drive gear A. All right, cool. That's what we've done. Let's hit play and see what we get. Well, it's getting a little bit jittery here, and you see it's shaking all over the place, and we will fix that in a moment. But what I would like to do is point out the way the dynamics visually are simulating. So let's hit Control D, and back under dynamics, back under visualization, turn on enable, and let's see what this is actually looking at. This is creating low poly proxies for everything, trying to make everything visually low poly. We're telling these to calculate as spheres. So essentially, you can see that's doing this little box around it. Now, it's not actually, that's not the actual calculation happening in this box. That's just a visual representation for us. The actual calculation for a sphere is incredibly fast. It's really elegant math-wise, because essentially all we need to know is, hey, is something inside of the radius of it? So it's like, here's a point in space. Are you within a distance of that point in space? Yes, you are. That's very accurate. It can calculate really, really accurately. If you've watched other tutorials of mine, you know I like using a floor object because it's an infinite floor that nothing can sneak through. Spheres are kind of similar, where it's really hard for the spheres to penetrate into something else because they're so clean and accurate. Now, let's deal with this jittering problem we're getting. I don't want to see this visualization anymore. I just want to show you how clean that is. Turning that off. Why is this jittering? Well, to tell you the truth, I don't know why it's jittering, but I do know how to fix it. The problem is that, remember we made this a compound collision shape? Something about Cinema, it just doesn't like that. It doesn't like the way this is combining as a single object. I honestly don't know what the cause of this is, but here's the solution. We are now looking at gear 2. Here's my fix. I'm going to hit Alt-G, and under Alt-G, I will move the dynamics tag up to the parent, and that can now be gear 2. And it just needs some other object put in it. It needs its compound collision shape to be more complex. Go figure. I don't understand. In this case, I'll create a cube. If I hold down Shift, it'll become a child of it and automatically take on its PSR. Hitting T, I can scale it way, 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 way down. E for move, and now you can see I've got this little cube, and it's just inside of it. Keep in mind, this is still a compound collision shape. It's still looking at this entire hierarchy and merging it down into one object. That's all we did. All we did is put this in the null, move the dynamics up a single object, and add a cube in. Without doing any other changes, check this out. As soon as I hit play, not jittering anymore. It's now smoothly pushing through there. I have to move where the connect is, but you now see it's not jittering. Let's fix that connect. The connect is currently looking at the gear. We don't want that. It's going to be a sibling. This is very similar to what we did in these other parts. That connector shouldn't be connecting to gear 2. It should be connecting to the null gear 2. And in this case, if I want to keep things very organized, I could rename this back to extrude, just so those don't get confused. You can see the connect. The connector is connecting to gear 2, the null. So with that all updated, let's hit play. And there we go. Now with that working properly, you can see by adding this cube in, it is now accurately seeing these spheres collide with it, and it just starts working. And just to show you how weird this is, if I turn off this cube, then immediately it starts jittering again. If I turn the cube back on again, then now it becomes solid. I don't understand it. If anybody can figure out why that's happening, I would love to know. Please put a comment. But in any case, we now got the sphere, and it can be as small or tiny or big or moved in any location, and it's going to be accurately calculating. So go figure. All right. So with this little fix notwithstanding, we can check out our spheres rotating, and that's actually doing a pretty good job for us. That is working well. We want to start working our way through the rest of them to make it calculate accurately. So let's complete this first gear. We've got our gear A. Now, that is really good for our simulation. However, we don't want to see these spheres. We want to hide them. So I think the cloner will be renamed cloner proxy. So if we make other cloners in the scene, I could always search for the word proxy and select all of them. In addition to that, we can hide it both from the viewport and from the renderer, so that won't show up. Now, here is the next cool trick for this tutorial. And it's something I didn't realize you could do. Currently, this is dynamically doing all the calculations. It's seeing all the children and merging them together into one object. We've got a gear here, this geometry. What if we wanted to go along for the ride? Well, we could make it dynamic and link them together with fixed connectors. We could maybe make a constraint tag and tell it to go wherever that one goes, but there's actually a really easy way to do it. And that is, we can just make this gear 1 a child of gear A. It's a sibling now of the connector and of the cloner, and it's hanging out. Now, this collider shape, this compound collision shape, is going to be saying, hey, that's another giant sphere. It's going to get calculated as a giant sphere. In fact, it might be nice if we can see that. Let me see if I can see it. This is off the rails, but let's hit play, go a frame forward, and I can see that not only is it calculating these, but there's also a big one getting calculated. That's probably going to mess everything up. We don't want that. So instead, we can copy the dynamics tag that we currently have on gear A, copy that, holding that control or command, onto gear 1. Then, under the dynamics tab, click off dynamics. Turn that off, and now you see that turns gray, essentially meaning this is not being calculated anymore. This is going to work its way down the hierarchy and combine everything as ellipsoid volumes to calculate the dynamics. But then it's going to bump into this dynamics tag and be like, oh, whoops, sorry, ignore you, don't do anything with that. So what's cool is this is a child of something that's a compound collision shape, but it itself won't be calculated. So all that calculation time is gone, but we can visually see it doing everything that we want it to. So there we go. That is a really great, quick combination of those just by using a second dynamics tag that is going to ignore those. So that is working quite nicely. Let's go through and update the rest of our gears. This one is going to be the next one. We don't need that cube anymore because of the changes we're going to make to it. So essentially, we just need the same ideas. Let's steal a bunch of the information that we just were using from this one. Its own dynamics tag is out of date. We can use the better new one from gear A. So under gear 2, I'll copy that over. This will now be renamed gear B. And of course, it needs its own cloner with spheres. So I can copy the cloner proxy over to it, holding on control. It's now a sibling of those, make it visible, view it from the front. And now we can see, hopefully, well, it's actually, we haven't moved it yet. So let's hit reset PSR. Boop. Jumps that over here. The other one's being hidden. I'm going to actually leave them all visible moving forward as we go. And then we can turn them off at the end. So you can see I've got this cloner moved over. It's a child in the correct spot. We know that there are 40 teeth on that one. So that can be 40. And we're doubling the number of teeth, which means we should double the radius. And immediately you see it jumps out. It is perfectly the correct radius. It just needs the proper offset. So on the offset, I'll right click on the up and down to reset the 0 and just increase this number until they line up really well. You can also go negative if that's quicker to get there. And like I said, if you want a 0.5, we'd say 0.5 and then 0.5 and increase the number from there until hopefully you get one lining up pretty well. That's pretty close. So with those lining up, it's already filtering this information down really nicely. So this extrude is the only thing causing us trouble. That means we can put this don't run dynamics tag, dynamics turned off, copy down to the extrude. So that should be ignored. The only thing left to do is make sure this connector is seeing gear B, which it is because it was already in that null. So that's correctly seeing the same thing. So with all of that in mind, we've now updated that. If we look at it from the top, you can see those spheres will be dynamically interacting with these spheres. So hopefully without changing anything else, we can hit play and that is just automatically working. This gear is starting to drive those and everything is spinning down the chain. Now the rest of them are choking a little bit. One thing, remember how I was getting all that jitter on that one? Well, we're not getting the jitter on this one, but keep in mind, this one is already a compound collision shape that is seeing two separate collections of the extrude. So that's actually something that's pretty important to keep in mind. Now, let's view this from the front and make sure that these are properly intersecting. And in fact, maybe that's the problem we're seeing right now. They're kind of choking a little bit. And I think it's because these spheres are a little big. They're too big for one sphere to slot in between the other two. Really easy to fix. Grab both spheres we have, both the spheres inside the cloner proxies. T for scale, just scale down until you see they're small enough. And you see how close we were. We were barely too big. So we want these actually to be really accurate. Really, the tighter they are, the smoother all the motion will be. But if we go down a little bit extra, as long as they can slot in between each other, that should be fine. So just by scaling that down a little bit, I bet you that that's going to run way smoother. So, well, those seem to be smoother. Let's look at it from this angle just to make sure that those are slotting between. You can see how accurately these are going, but I think that it's still fighting us a little bit on the next series. Let's not worry about that too much as we continue replacing all of the shapes that we're feeding in. Now, it's going to get really quick from here because I think we should just rebuild this gear. Actually, let's just rebuild everything from this point forward from our existing new parts, because it's going to be quicker. So I can delete those other ones. And obviously, if you're building this in a big, complex scene, it's going to be a good idea to build these from scratch as we go. I just want to really step our way through. So with that in mind, copy gear B. It becomes gear C. Gear C. I'll just scoot this over. We know that this extrude is going to need a sibling, and that cogwheel wants to be all the way down at 10. That can scoot forward whatever visual amount that we want. Then we have this cloner proxy, which is currently all these spheres on the outside. We can see it better from the front. Those are all on the outside, which is cool, but I want a duplicate of that. Now we know that there are 10 in the count, which means that we want a radius of 1 divided by 4 divided by 4. Boom, instantly locked in. The offset just needs to get tweaked a little bit until these are pretty well lined up. And with that in mind, I think we just grab this gear, scoot it until, actually we want this small gear to be the one intersecting. So I wasn't looking at that. Let's scoot that over, and now you can see how those are interlocking pretty well. And then let's make sure from the top view they're working. So middle mouse button, look at it from the top, scoot this over. And actually, I need to make sure that the small one gets scooted forward so it's in that gear. And honestly, if we were inclined, all these other ones are back a little bit. Visually, it would still run, but I would like them visually to line up a little bit better. So I'm going to grab this chain of clones, that cloner proxy, that cloner proxy. So all the big loops of them, and just scoot them all forward. In fact, we can center them inside of those gears. So we'll just kind of work at everything being in the center from here on out. So if we have our final gear, gear C, we want these small ones to be what's lining up with those front ones. So scooting those in place, that should be working quite nicely. Now, not the biggest deal, but this is slightly intersecting visually. The spheres aren't, but the gears are. So you know what? I'm going to scoot this a little bit extra back, get that little bit of gap in there. And then that does mean I want to grab the small gear and the small proxy and scoot those until they're lined up again. So in this case, I think it's even a nice idea to rename this proxy small, and this one can be proxy large, just to keep those distinguished from each other. So now, with these spheres swapped out, hopefully we can hit play and immediately see this gear turning, working really nicely. All right, we just made that last gear that we needed. It's really quick to make the next ones. So copying a gear D from the top view, super quick. Just line up this front small gear with the bigger back gear of the other one. And then from the front view, make sure that on the x-axis it's properly lined up. Nice. And there you go. Gear D, that simple. Gear E, same idea. From the top view, scoot this to line up right around there. And you see how sloppy I'm being. I'm not being super precise with these. They're not perfectly lined up. And from this point of view, make sure that those are lined up, intersecting, or, you know, slotting into each other very accurately there. And even here, you can see that I think these are maybe like there's a little bit of a bump there where they might hit, but they'll sort themselves out very quickly. You can also rotate them to make sure that they're not inaccurate. But now that we've done that, all these different gear setups, move the motor to the top just to stay organized. Do another save for ourselves as number 5C and hit play. And let's see what we get. All righty. Now, what are the results? We're back to where we were before, but we've remade everything from scratch. Well, this is actually looking pretty good for us. We can see that this is spinning, and look at our FPS. We are now consistently, instead of being around 30, we are running around 90, 93-ish, seems to be, maybe 95 is an average of what we're getting. Now, I did accidentally, well, sort of, I didn't, we were copying the tag from one to the next. So I think we messed up some of our weights. So all of these currently have a different masses. This first, actually, they all have a mass of 10 now. So if we're going to make it similar to what we had before, this could be a mass of 10. These other ones will be a mass of 1. And then that last one we had set to a 0.1. And now we're back to where we were before. So now you can see that they're spinning really fast, and look at how quickly, now that we're up at our frames per second, you can see how quickly this is like, okay, getting up the speed. We are now way more accurate and running at 3 times the speed. What's crazy to me with this setup is, in spite of cranking up in spite of how quick this is going and the fact that we're still, hit Control D under Expert, we're still at a steps per frame of 5. And with all these cloners, we created a bunch of clones and a bunch of spheres. We know that cinema doesn't like a lot of different objects. This is still so much faster, and it is more accurate. If we were to keep on pushing this effect further and further and further with more and more gears, the other one you saw that the intersect, actually that's the point that we should do here. Let's zoom up on this and see if these gears are going to start passing through each other. And I just know from experience from doing this a bunch of times, they will not. These spheres are very cleanly, let's go find this first one. They're just going to slot very cleanly and perfectly between each other. Now, you want to make sure you get the scale right. You want to make sure that they're not passing through each other initially too much. But now that that's working, all of these can go and look at the next one, look at the next one. And this one is going so fast. Look at how quickly this last one is spinning. Oop, ran out of time. Look how fast this one is spinning, and it's still running accurately. It's just really cool. And this gives us a good kind of foundation, a good bedrock for us to do future dynamic tutorials. So I will be referring back to this one in the future for sure, because man, I just love these types of dynamics, and swapping all of this out is just so powerful. This is so quick. And the trick of adding in these extrudes as a way of hiding what's underneath dynamically, it's like they're dynamically invisible, like so powerful. Now that we have done this, we can save the scene file, and I'll probably immediately save it as another copy. And we can now change these gears to look however we want. We are free to do that very easily. Oop, don't misclick there. Click this last one under the cogwheel itself. We can go to the inlays, change this to have like holes inside of it, give that a radius of 3. Oops, those shouldn't have a radius of 3. The ring radius should be 3. Now you can see we get these nice little holes in there. That could crank up to 5. And we can go through on every single one of these gears and change the way that the gears are drawn. And there's a lot of really cool, different types of gears that the cogwheel affords us. In the inlay, that's holes, but we can give it spokes. And man, I just love the way these look. Jump up to 3, you get these big spokes. Select this one and change that to waves is a weird one. Outer radius of there, you get these waves and the different counts of them. So you can see how you can very quickly layer those up. And in addition to that, selecting every single one of these extrudes, in fact, I'll just search for the word extrude, click the magnifying glass, search extrude, grab all of them. Under caps, we can give it a little bit of radius. Let's set a radius to what, 0.1. Keep in mind how tiny everything here is. So a 0.1 radius on there is going to round these. If we want it to be sharper, set the segments to 1. We could also change, we've got all the different presets that we could load. I haven't even tinkered with these too much, but yeah, we can click any one of them and you're going to see we can get some crazy looking gears. Like, look at that. I mean, obviously that's not something we'd want, but all these different ones are valid. We could do this one where they curve in. Oh, look how cool those look. Like, that's really cool. Just make sure they don't intersect too much. And it's just a lot of fun. Set the radius correctly and yeah, change these shapes to whatever you want them to be. Going back to the default seems like a good idea. Basic rounding. And the radius down to 1, segments of 1. Actually, no, we weren't 1. We were at 0.1. There we go. That's going to be more accurate. So now you can see that we have this. If I hit NB as a shortcut, we can see all this extra geometry being generated, but the dynamics don't care. The dynamics aren't looking at these extrudes. They're not looking at the cogwheels. They're looking at the little spheres that we made. So no change that we just make is going to affect the speed of the dynamic calculation. If we hit play, this is still going to run exactly the same. I mean, of course, cinema is taking time to generate the extra geometry, but that doesn't have any effect as far as the dynamics are concerned. Now, we did very specifically rename these cloners proxy. So, in your scene file, obviously you might have like a different cloner with doing something else. So by calling those something unique like proxy, I can just search for POR and you see all the proxies show up. So now it's really easy to search for proxy and then hide all of the spheres. And if you double click and paint, then you can actually paint up through. All the spheres are now hidden. Nothing else was affected. And now those spheres are hidden. We don't see them, but those are what are doing all the calculations. All the gears are looking great, running really fast, and we just have complete control over them. So I highly, highly recommend tinkering around and going further and seeing what kind of simulations or calculations you might be able to do with this. It's really, really fun making mechanisms. In fact, here is an example of something I made a long time ago when this cogwheel first came out, just having fun. And this is really being driven by this flow of particles coming through, that's actually creating weight, which is making everything else turn. Now, back in Cinema, here's one of my test files. We're not going to explore this too far, but just as a way of opening up your imagination and things we might end up doing in the future, I actually made a worm gear over here. So here's a bunch of spheres creating that worm gear, and I could select that and hide them. And as that spins, it's going to spin this gear down here very slowly, so that's fun. But then even more, kind of did that railroad thing like an old locomotive where this is connected. There's a connector here and it's causing that to spin. And as that spins, this is set on a linear rail. So this can only go forward and backward. And that is now translating constant rotational motion into an alternating rotating motion. So as we look at this, you can see that this is doing a quarter rotation, so 90 degrees. But this one is doing a 180-degree rotation back and forth, even with an ease out. And this last one, geared down to be double this one, is going to be doing a 360 rotation. So you can just start having fun with all these things combining. I plan on doing more with this type of dynamics in the future because it's just really, really fun. Now, of course, a lot of this was sort of an exercise in just making things dynamic and making them real. But as we go further, there's reasons to make things dynamics. Of course, you could have used Espresso and had one line drive the next one, which drives the next one. You could do that using the straight math. But there's something to be said for the satisfaction of actually making the machine that runs and using these spheres to approximate the locations of these, but letting the dynamics actually do the driving of it. Like, I don't know, it's just really satisfying seeing these run and get, gearing up the ratios and translating everything and actually letting this motor do its work. If we add more and more of them, like the actual weight of the different gears weighs it down and you can make them do real work here. So this could be driving the wheels of a car. It could be driving a claw machine. Who knows what types of things might get built in the future. That's going to wrap this one up. If you liked it, a like is appreciated. If you have any comments or thoughts on this, things you'd like to see in the future. Also, keep in mind that on this tutorial, I did a little bit of an experiment where I took some of the key ideas and made a fast forward version of this tutorial where it's jumping in the meat, assuming you know Cinema a little bit more detailed. These tutorials I tend to step through as if maybe somebody doesn't know anything. It's the first time they're watching a dynamics tutorial and here they can learn the details. But maybe people are interested in like, no, I get the basics. Let me get into the meaty parts of it. So that's what the fast forward is. So check that out and let me know which format might work better for you. Now, if you liked this and you found it helpful, let's say you did a client project, you got a really cool render out of it, I actually have a Patreon set up. So if this was helpful to you, then support is super appreciated. You get access to bonus live streams. These tutorials get recorded in front of a bonus live stream. So that's kind of fun. And the ideas from people there lead to a lot of the tutorials. In addition, you get access to the scene files. As I said, you get access to the scene, or not the scene files. You do get the scene files, but you also get the tutorials a week early. So all that stuff layers up, but all the cool stuff ends up out there for everybody for free. So thank you so much for watching. I'll see you in the next tutorial or the next live stream, and that should do it. Bye-bye.